What's up guys, welcome back to my channel. In today's video we'll be talking about the vector equation of a line. Before we look into any of the examples, let's try and understand the basics of this subtopic, vector equation of a line. So before we write anything up, let's just assume we have a line going over here, and we'll name that lambda. Sorry, not lambda, alpha. The line is alpha over here. And we've got another vector, which is going to be vector v. So vector v equals to ax plus by plus cz. So that is this vector v. We'll draw it over here. Parallel to the line alpha. That looks parallel to me. Yeah, so that is parallel. And we'll denote 2 points on the line alpha over here. This can be A initial and A over here. A initial and point A. A initial can be written as x initial I plus y initial j plus z initial k. That is A, and vector, there's A initial, vector A would be x of I plus y of j plus z of k. Correct? We've been given that. Vector equation of a line is defined by r. We have vector r equals to r initial plus lambda v. Why we get that? Let's look at this. V is parallel to alpha over here, and we can denote this as a initial a. A vector that is parallel with v. Vector v. Therefore, can rewrite this as a initial a equals to some scalar scalar magnitude multiplied by v, because it's parallel to this. This has been given. This is the vector we know is r initial. That is r initial. Correct? R initial vector over here. And we know that this is going to be r. This is the vector equation of a line. That is r. Vector r. R initial is vector r initial. This is vector r. Therefore, we get r initial plus a initial a. So r then equals to r initial plus initial a. But this in this case is lambda v. Plus lambda v. So that is how we can equate, or that is where the vector equation of a line comes from, is vector r equals to r initial plus lambda v. Which is demonstrated over here. Now let's look at the first example. Looking at this first example, it says find vector equation of a line joining points x, 5, 2, 6, and y, negative 3, 4, and 1, and find points xy when, find the points of vector xy when lambda equals to 2. First step, let's figure out what ox is. Vector ox is 5i plus 2j plus 6k. Correct? And xy in this case is vector y minus vector x. So minus 3 minus 5 is negative 8i. 4 minus 2 is plus 2j, and 1 minus 6 is minus 5k. In this case, So the equation of this line is going to be vector r is lowercase x. We'll denote this as lowercase x and lowercase, we'll go b, lowercase b. So this is going to be x plus lambda b, correct? It's going to be the vector equation of a line. So r then equals to x is this. 5, we'll write in component form, 2, 6, plus, sorry my bad, plus a lambda, this over here, -8, 2, -5. So that is the vector equation of the line. Now we're going to find the coordinates for when lambda equals to 2. Let's separate this in terms of their parametric form. So x equals to 5 minus 8 lambda, y equals to 2 plus 2 lambda, and z equals to 6 minus 5 lambda. Correct? Next step, we know that lambda equals to 2, so the points x, y, and z for this vector over here, we just sub in 2 for lambda. So x then equals to 5 minus 16, -11. Y is 2 times 2 is 4 plus 2 is 6, and z is 6 minus 5 times 2 is 10. 6 minus 10 is -4. Therefore, the coordinates are, we get -11, we have 6, and we have -4. That is how you do example 1. Now we'll go on to the next example.